All right. Third section here in honors geometry. Now we're going to be talking about collinearity, betweenness, and assumptions. That last one's a big one. Okay, what can we assume? What can we not assume in geometry? Because it can be very easy to just assume things from diagrams when we really cannot. All righty. So let's hop to it. First off, collinearity. Collinear just means the points lie on the same line. Co-linear, linear being line, right? They're on the same line. Cool. All right. I'm just babbling. So any 2 points are going to be collinear. No matter where 2 points are, I can draw a line through them. Am I guaranteed to get 3 points on a line? Sometimes it might work out, but sometimes it might not. But still, any two could be on the line. So in this diagram, we've got point A, P, and B. To answer that third thing there, name 3 collinear points from the diagram. A, P, and B are collinear points. They lie on the same line. On line looks like a lowercase l. Okay. Betweenness. So betweenness just means that a point is between 2 points. Nothing more. As far as being exactly in the middle or not, right? We don't know if it's exactly in the middle. It's just somewhere between, okay? So C is between A and B if, this gets kind of weird, AC plus CB is equal to the entire thing. Visually, I think that's just like common sense, okay? And then also A, B, and C have to be collinear, okay? So I can't say that if it were like this, A and B, sorry guys, the Siri on my phone was popping on and off. Weird. All right, and then they're always listening. And then we got C. C is not between A and B. They have to be collinear to be between. Okay? Cool. And one last thing about collinear and betweenness. If you have betweenness, you know that they're 3 collinear points. If you got collinear points, you know that a point has to be between the other 2, right? If you got 3 collinear points, one of them's got to be between. So they work with each other. They're good friends. All right. So it says Q is between P and R on a number line. P is at -8 and R is at 4. Let's think of this as like a number line with just integers, okay? What do we know about the coordinate of Q? What do we know about the length of PQ and QR? Why don't we draw a diagram? I think that's helpful. So I'm going to draw a number line. We'll say this is -8 right here. I'm going to throw a 0 in because I like to throw 0 on my number line, and then 4. So we're going to say that P is right here, R is right here. What do we know about the coordinate of Q? Well, Q is between, so I guess what we could say is that Q is somewhere between -8 and 4, right? So Q, and we could even write that maybe as an inequality. It's between -8 and 4. Its value is somewhere along there. Cool. It's not going to be -8. It's not going to be 4 because it's between them, so it can't be equal to. All right, what do we know about the length of PQ plus QR? Well, let's just say for fun, I'm going to throw Q somewhere on you. Let's say Q is right here. I don't know what number that's at. But in any event, I know that PQ, the length PQ plus the length of PR will add up to the full PR. Or we could say a length of 12, right? From 8 to 0 is 8. Or sorry, from 0 to -8 is 8, a distance of 8. Even though it's going in the negative direction, it's still a positive distance. If I walk backwards, I'm still moving a positive distance, right? With a dope moonwalk. All right. So 8 plus 4 gives me that 12. Triangle inequality. So given that A, B, and C are non-collinear points, right? They do not lie on the same line. They form a triangle, right? So then 3 things are true. And I want to point one thing out here on this diagram. Across from vertex, let's start with A. Capital letter A for a point, right? And that's the vertex. Across from it, we have a lowercase a. That's notating the side A with a lowercase letter, just to make it a little bit easier than saying BC. You'll see that comment across from the angle or the vertex. You'll see the lowercase version of that. Same here for B and the same for C. So what 3 things are true? And I'm going to use A, B, and C lowercase letters to notate the sides. Well, any 2 side lengths are going to have to add up to larger than the third side. What I'm saying with that is that if I took the lengths of A and B, they would have to be larger than C. Because if they weren't larger, then they wouldn't ever touch and form that triangle, right? If the length was less than C, then there'd be like a gap and you couldn't make a triangle. And we can write two more statements just like it. We could say B plus C is going to be greater than A, and A plus C is going to be greater than B. All right. Another way of formally writing it, which we already said, is that any two sides add to larger than the third. Something like that. Okay? Cool. Fantastic. So here it says, what are the restrictions on x given the triangle below? What theorem did you just use? Oh, spoiler alert, probably the one we just learned. But anywho, let's do it. So what can I have for my length of x? Well, there's going to be a minimum amount and a maximum amount. Like I can't go crazy huge on this because otherwise that's not going to form a triangle. Well, let's see here. I said any two sides need to add to larger than the third. Let's take the small one of 5. So 5 plus what would give me 12? 7, right? So then x has to be larger than 7. And if I'm doing a compound inequality, I know I'm going to have to be larger than 7. But I can't go too big, right? Well, the other two sides, 5 and 12, I want to make sure that the x side doesn't exceed the length of those two, because then we're going to have that gap, right? So 5 plus 12 is 17, so I'm going to have to be less than 17. Otherwise, they won't touch at B, and we won't have ourselves a triangle. All right. Some of you may notice that the difference of 5 and 12 is 7. The sum of 5 and 12 is 17, and that is something that will always happen. That will always work. All right. So we just use the triangle inequality theorem here. All righty. Assumptions. These are things you can assume. You can assume straight lines. We mentioned that in the previous video, and straight angles. Okay. So if it looks straight, boom, straight line, boom, wonderful. If I got 3 points, I know that that's a straight line, straight angle, whatever, however you want to use it. Collinearity, I can assume that, right? If I have a diagram like I just drew, that's great. This works out well. If I have a diagram where there's a line drawn through the 3 points, 4 points, whatever, I know they are collinear. I can't assume collinearity if I see this and there's no line drawn through. I cannot assume it. There has to be a straight line drawn through. If I can assume a straight line, I can assume those points that are on that line are collinear. And with collinearity, I get betweenness, right? If I have 3 points, one of them has to be between the other two, so I can assume betweenness. I can assume this guy's between the other two. I cannot assume that over here because they're not necessarily collinear. Oops. Didn't mean to move that guy like that. Alrighty. Not assuming. Okay, no assuming on this one. You cannot assume congruent segments without markings. You can't assume right angles unless you see an angle like this and it has a mark, right? Okay, I can't assume congruent segments even if they look it unless I've got the tick marks. I can't assume congruent angles even if they look it unless they've got the marks. Okay, then I can assume relative size of segments or angles. I can't assume that like, oh, it looks like it's bigger, it looks like it's smaller, unless it's confirmed, okay? That's when we're talking about like on diagrams, okay? Obviously in real life, I think it's helpful to maybe assume some things like, I think that thing's bigger than that one, right? But in diagrams, in your structured, traditional geometry like we're doing here, you cannot assume a relative size. I can't say, I think that's about 60 degrees. I think that's about 40 degrees. No, can't do that here and work through a problem with those assumptions. In real life, sometimes, making a judgment on something is great. But in these problems, we're going to need to really be certain about things, okay? So there's a little bit of give and take there with real life versus, your traditional geometry. We're going to try and link both together. I love doing that. All right. So let's do a few things here. We want to name 3 collinear points. Well, they got to be on the same line. I can assume a straight line so that R, S, and T, they lie on line segment RT, or they lie on line RT if you were to continue it on forever. So R, S, and T, those guys are collinear. Can you assume that JR is congruent to KT? Do they have congruent marks? Heck yeah. Yes, I can. Can you assume that angle R, which is right here, and angle T, which is right here, that didn't have any marks, can you assume that those guys are congruent? I mean, they look pretty darn close, but remember, I can't use my looks to say that they're congruent. So in this case, no, because I don't have the markings. If I had markings, I could. Can you assume that angle RST is a straight angle? We can assume, if it looks it, that it's a straight angle. If it's a straight looking line, we can assume that one. All right. And name a point between R and T. Well, since RS and T are collinear, right, because we assume it was a straight line or straight angle, S is going to be between R and T. Cool? Wonderful. I'm going to skip the ticket to leave, keep this video a little shorter. I'll give you guys a little more time to work on some H-dubs. All right. You guys have a fantastic day. And wonderful, I don't know what else. All right. America, freedom, rock and roll. Make sure you follow Riverdog Jenny if you haven't done so already on the gram. You should become a gram famous.